Hello everyone, I am Changsun from KARI. So my presentation will be about the R&D program for civil UAS in Korea.
R&D 시스템 중에서 특별히 저희가 이제 그 K-100이라고
As for civil UAS, we have KIAST 100. This is used to be a small light aircraft, but we were transitioning into an unmanned UAS.
먼저 국제 기술 동향을 한번 살펴봤습니다.
Let's take a look at the international trend.
분야에서 기술 선도에 가는 기구는 이제 ICAO.
So ICAO is the basic standard for standardization of civil UAS. So we are using ICAO's SARPs. First, licensing in Annex 1. That was announced back in 2018.
인증 관련된 에어워스니스 같으면 이제 안엑스 A 시승했는데.
And back in 2018, the draft for Annex 8 and Annex 10 was announced.
그래서 이걸 각국에서 시행을 하게 되는 건
So I think it would take time for countries to fully adopt it. So the full implementation is expected in 2023 or 2024. And in the meantime, various demonstration projects are being pursued. So KIAST 100
항공기로서 4인승 항공기가 개발이 됐고요.
was first developed for the certification purposes.
사업을 진행을 한 바 있습니다. 무인 항공기 쪽에서는 이제
In the UAV, until last year, operation safety was examined. So we are trying to develop the system for certification technologies, especially in terms of airworthiness. Depending on the altitude and the type of aircraft, we can categorize different aircrafts. Below 100 kilograms, 150 kilograms, and over 600 kilograms. And when you look at the altitude, there is 150 meter and 300 meter and 4.3 kilometers. And for this project, we are looking at the aircrafts of more than 600 kilograms and that can fly over 500 feet. Just like the UPOP project, our project has been implemented around the same time, and we've been pursuing for 5 years. And it is also funded by MOLIT, and KC-100 is now being converted to the unmanned aircraft system for a certification basis. So these are different entities involved in the project. Under MOLIT, there is KIAST and KARI. We are the supervising body of this project. There are 4 different sub-projects. First sub-project
flight control 시스템에 해당되는
is about the flight control system.
수행을 1과제 항공우주연구원이 수행을 하고
And that is being conducted by KARI. And KAI, which developed KS-100, is also involved in the second sub-project. And for the third sub-project, ground control system data links are being developed by StarTech. So at KIAST, they confirm the compliance of certification
협력을 해서
as part of the fourth sub-project.
인증 인프라를 구축하는 그런
And their combined effort will build the necessary infrastructure for UAS in Korea. So these are key milestones.
개발 사업이다 보니까 이제 세계
Since we're developing a new aircraft, so we have different phases. Starting in 2019, conceptual design, preliminary, detailed design, review, SRR,
설계
SDR.
2020년도 때
And back in 2020, we reviewed our preliminary design. Last year, October, we also conducted a critical design review. And based on the results, we fabricated the vehicle and we conducted the unit test.
체계에 대한 체계 엔지니어링 파트가 있고
So there is the engineering part of this project, and there is this certification related project.
플라이트 컨트롤 시스템
There's flight control system, airframe, data link, ground control system. These are the involved elements or components of the project.
지금 2022년도
Now we are in 2022, and this is February. So as of now,
전체적으로 통합되어서
these individual components are being integrated into the UAS
비행 시험을 할 수 있도록
to be ready for ground test or flight test.
시작되고 2022년 말 정도부터 이제 비행 시험을
So I think we will be starting the preparation for flight test as end of this year.
예, 개발 전략을
And let me give you our R&D strategy. There are two categories.
있고 그
So there is KC-100. So based on this, we are building UAS and also developing
하는 방향으로 진행을
compliance technologies.
항공기를 좀 더 설명을 드리면
So if you're interested, this KC-100 small aircraft, it was a 4-passenger aircraft.
항공기를 개발하기 시작해서 2013년에
And
이루어졌고요.
the development was done in 2013.
이제 형식 증명, 생산 증명
Type and manufacture or production certification
획득을 했고
were obtained from MOLIT. Because of the COVID, there was some delays.
걸로 그런 비행체입니다. 그래서
So I believe we also obtained additional approval as well.
공군의 그 상한학교에 훈련용 비행기로
We provided 25 aircrafts to the Air Force Academy for pilot training.
비행체가 두 대가 있습니다. 형제 이제 받은 비행체가 하나 있고 하나 시범기로 갖고 있는
So now we have 2 for test and evaluation, 2 for prototype,
해서
and another one for certification.
예, 재원을 보시면은
So let's take a look at the specifications. The length is around 8 meters. The width is like 11 meters.
속도가 이제 380km/h, 최대 운용 고도가 한 7km.
Maximum cruising speed is 389 km per hour. Maximum operating altitude is 7,620 meters.
개발하는 전략은 저희가 이제 KC100을
To add, in terms of our R&D strategy,
형식 인증을 받은 비행체
this is the first aircraft that won the type certification.
으로서 인증 기술 개발하려고 하면은 거기에 많은 이제 비용과
And to use this for
기술들이 많이
compliance certification, we need a lot of different technologies.
인증받은 비행체로서의 그 기술들은 가져오고 무인
So we are going to use KAC-100 to use its already certified and approved elements and add specific or special components of UAS
인증 기술을
or UAV
하려고
for UAS compliance.
그래서 시스템의 체계 개발하는 부분이 있고요. 그 아울러서
So we are building systems.
인증 기술 개발하는 쪽에
Also, we are developing certification technologies.
식별과
We also identify necessary standards,
식별하고
develop CCL or compliance checklist.
식별하고 확인하는 그런
In addition to certification basis.
인증 쪽에서 협력해서
So
이루어지게.
there is the alignment between development and development of systems and development of certification technologies.
인증 기술에 대한 국내에서 인증 기준에 대한 연구 결과와 그러한 것들에 대한 축적된 기술.
So our research, accumulate data, and infrastructure will be developed based on these.
인증 기술 개발 내용은 또 내일 특별히 또 인증 및 산업 편전 동향 해갖고 9시에 항공안전기술에 대해서 무인 항공기 시범 인증
KIAST
발표가 있습니다. 그래서
will have another
잠시로 보시면 되겠고요.
presentation tomorrow at 9. So I think that will give you more detailed information about this.
수정되지 않은 거는 파트 2, 3을 사용하고 그대로
So as for KC100 certification, we're going to just use the KS Part 23, but we are going to add special conditions due to some changes in the design to identify what is the necessary compliance technologies.
인증 관련 기술들의 이제 중요한 산출물 결과물이 되겠습니다.
So let's take a look at what are the key deliverables here.
시스템에 대한 인증 기준 이런 것들이 셋업이 안 돼 있는.
We don't have any certification basis yet. They are in development.
대해서 식별을 하고.
So we are going to identify what kind of certification basis we need.
활동을 하고 또 이제 인증
And additional validation activities will be done.
보고서들이 3차년도, 5차년도에
And the third year and fourth year, we are going to also prepare some reports based on the activities so far.
컨옵스입니다.
Let's talk about CONOPS, or concept of operation.
무인 항공 시스템으로 개발된 비행체를 공에 있는 국가 종합 비행성능 시험장에서 시험을 하려고 합니다.
So we are going to test the aircraft we have for unmanned operation. We are going to use 2 GCSs. The data link will cover around like 50 kilometers, and that will be used to test the handover function on the shore. We are going to conduct the monitoring.
운영하는 그런 이제 운영 개념이 되겠습니다. 네, 지금 각 시스템별로 개발되고 있는
And these are components
설명을 좀
being developed for the system.
시스템 중에서 플라이 컨트롤 시스템,
First, flight control system.
데이터 링크,
And also, if you look beyond this, there is data link too
비행체와 지상
that will connect the ground equipment and the aircraft. And there are other very important devices for control. As for FCS, flight mode selectors, actuators are included, and surface control too, ADT, GDT,
비행 통제 장비들하고
and other controllers,
조정 장비하고
also controlling control modules, display.
인증 관점에서 시스템을 개발 이제 해야 되니까 병지역
Since we need to develop a flight control system for certification, due to the reliability issue, we of course went for redundancy.
다중화, 삼중화돼 있는 시스템이
So
되겠고
it's like not just redundancy, like triple redundant system.
입력 센서 눌러서 항법 센서하고 GPS
Navigation sensors, GPS, INS,
트랜스펀더,
transponders,
기준의 충돌 기능으로 사용하는 장비가 되었고요. GPS INS하고
GPS, INS.
항법 고도계 이런 것에 대한 항법 장비가 되겠습니다.
These are for the airborne navigation. They are triple redundancy. We are using actuators developed and manufactured in Korea.
이제 스로틀까지 이중화된 작동기를
And we also have secure redundancy for aileron to elevator rudder and throttles.
아링크 429 그리고 캔 통신.
We also use CAN communications bus system.
네, 중요한 플라이 컨트롤 시스템의 소프트웨어 쪽입니다. 소프트웨어는
Let's take a look at the software side of the system.
FCC 하드웨어 안에 들어가는 비행 운영 프로그램은 OFP가 있겠고,
We have
그리고 이제
OFP,
비행으로 진행하기 위한 비행 제어 소프트웨어가 있겠습니다.
flight control software.
개발 절차에 따라서 요구도가 있고 요구도
Different software programs are being developed according to the procedure.
로 개발을 하고 있습니다. 그 개발된 것을 오스코드 제너레이션을 해서
OSCO generator is used to run hills
검증을 통해서
and validate the software.
개발을 하고 있습니다.
That's how we've been doing it.
네, 플라이 컨트롤 시스템 항공우주연구원 1세부 쪽에서 수행한 2021년도 결과.
Back in 2020, this is the results for our flight control system development program.
비행 운영 모델을 들어가는 파라미터를 저희가 다시 획득하기 위해서 비행 시험을 진행을
We conducted flight tests to acquire necessary parameters.
비행 운영 모델에서 파라미터를 새로 업데이트를 해서
To update the parameters we have and
하기 위한 노력을 했습니다. 하고
develop a simulation scenario that looks a lot like the reality.
수행하고 있는 단계가 되겠습니다. 또 하나 이제 30% 크기의 이제 소형
We also have a
항공기를 만들어서
third size KC-100 for flight test.
예, 관련된 플라이 컨트롤 시스템의 인증 관련된
These are the certification related activities.
2주에 한 번씩 정기적인
Every 2 weeks, we have a working group with relevant stakeholders to assess the progress of the sub-projects and define requirements so we can decide on the necessary components of the compliance. And then airframe, so modification of airframe. We have modified the KAC-100. We removed the seats,
각각의 항법 센서 그리고 경제 컴퓨터
avionics, navigation, flight control systems, electronics, flight control computers were mounted on the airframe.
그래서 조립 공정이 되겠습니다.
This is the assembly flow.
밑에가 있는 게 이제 기존의 항공기 캐시를
So
하고
on your far left, that is the
드러내고
initial stage. We removed unnecessary parts for unmanned piloting, and then we added gradually the components for the unmanned flight. So we have developed different necessary components, and we are testing different systems. So soon they will be fully integrated into the airframe for test flight.
비행체 중에서 각각의 그 작동기 클러치
Actuators, clutches.
액추에이터 시스템들이 이중화되어 있어서
So actuator systems have redundancy, and then clutches were used for additional layer of redundancy. That means like triple redundancy. And we also made an iron bird for testing. As for the electric systems, we also added a flight control computer.
SU와 SEAL 이런 장비를 통해서 시험 평가 중에 있습니다.
So we are using seal for testing, and we also added wire harness.
마찬가지로 이제 인증 관련된 병체 개조 부분에 인증 관련된 항목들 식별.
So for the certification basis, we check what we are going to need for certification when it comes to modification of the airframe. Then ground control system is also have redundancy, C-Link, EHF data link, GCS data shelter will have it all to support communications. They are all integrated into a single system. There are consoles for control the flight. Of course, there is a HVAC like air conditioner.
그라운드 컨트롤 시스템의 미션 컨트롤 쪽하고
And it shows two consoles, mission console and pilot console, and different elements for the system, and they are also now being tested.
데이터 링크 쪽에
As for data link, it is also redundant. We are using very high radio frequency.
개발되어 있고 각각의
We have terminals, and different components have been tested or expecting trials.
인증 관련되었고 이제 그 사세부에서 수행한 부분인데
So that is the certification basis we have identified from the fourth sub-project, but the details will be explained tomorrow's presentation. This is the report on the compliance basis for small unmanned aerial vehicle system.
사업을 통해서는 이제 운항공 시스템이 앞으로 무인기가 활용이 이제 무궁무진해서
So UAS have unlimited applications. There will be growing demand in the market. To truly commercialize it, before that we need the certification. But the industry standards for certification have not been fully established yet. So now we are needing the effort to develop the standards and also necessary systems. And through this development, we are going to use the proven technologies for compliance. So these are the these will be very important deliverables from this project. That's all for my presentation. So I also have a video to play. Can you play for me?
공항공센터에서 작년에 10월달에
This is the test flight from last year. I think it was in October. It runs in the middle of the runway and takes off automatically.
사전에 계획된 임무 프로파일 따라서
Following the pre-programmed mission profile, the aircraft flew. So it was automatic landing, automatic taxiing, automatic taking off. That was the three main goals of this trial.
축소기로 배행하게 된 거는 이제 KC-100이 갖고 있는
So KAST 100 has its own characteristics with this landing gear.
좌우 랜딩 기어에 차동 브레이크를 통해갖고 이제
They have different brakes on its left and on its right to decide or control the direction of landing. So when we were developing
컨트롤이
this aircraft,
어려움 없이 진행될 수 있을지 보는 거 하고
we wanted to make sure the control is done right
수직이 착륙 같은
in terms of landing.
고도를 기준으로
Vertical
하게 될 텐데
landing
보정이 항공기 같으면
is for fixed wing, I guess.
이런 것들이 지켜져야 되고
And the angle should be also considered like altitude.
거기에 따라서 비행을 해야 자동 착륙이 이제 원활히 이루어질 수 있는
So these factors should be considered to make sure vertical landing. So we wanted to test it out with a smaller, like scaled down version.
착륙하기 전에 네 포인트로 이제 착륙 지점들을 설정을 해놨고요. 그 지점들 지나가는 고도와 거기 따른 속도
We had 3 different landing points to see how this machine responds to it.
3에서 5도 사이에서
Between 3 to 5 degrees angle,
로에 안착하는 그런
the plane landed on the ground.
약간 측풍이 있을 때 이제 크랩 비행할 수 있는 그런 기능도 들어 있고요. 예, 발표는 여기까지.
So that's all for my presentation.
발표를 들어주셔서 감사드립니다.
Thank you for listening.